In this video, I'm going to show you what projecting vectors look like geometrically and algebraically. So I've already graphed vectors u and v, and we want to find the vector that's the projection of u onto v. So how do we project u onto v? Well, I want you to focus on the vector that we're projecting onto, so vector v. And we're going to extend this line extend it if you need to. Sometimes you don't need to, but we need to draw a line segment perpendicular to this line that goes to this point. Okay, so this is perpendicular, and this vector is what we call the projection of u onto v. But they want us to find the projection, so we need to find it in component form. And there's a formula for that. The formula is dot product over magnitude of the vector that you're projecting onto squared times the vector that you're projecting onto. Okay, so we need to plug u and v into this formula. So how do we do that? Let's start with a dot product. How do we find the dot product of u and v? The dot product is going to be x component times x component, so 1 times -2 plus y component times y component, so 3 times 4. Okay, now we need to find the magnitude of vector v. So what's the formula for that? The formula is square root of x component squared plus y component squared. And we're squaring the magnitude, so we need to put a square here as well. Okay, and we need to copy vector v again. You can use a calculator to simplify this, but I'll do it by hand. So this is 4 plus 16, 20. Square root of 20 squared is just 20 itself. Okay, so this is just 1/2 times vector v. So we can go ahead and plug vector v into this. What's 1/2 times -2? -1, and what's 1/2 of 4? 2. Okay, so the projection of u onto v is -1, 2. So this is your answer, but they also want us to express u as the sum of two orthogonal vectors. Now, what does the word orthogonal mean? Orthogonal means perpendicular. So if we wanted to express u as the sum of two perpendicular vectors, which two vectors in this diagram can we use? We can use this one, so the projection, as well as this one. Okay, so here. So u is going to be projection of u onto v plus, I'm going to call this vector w. Okay, and u was how much again? 1, 3. What was the projection again? -1, 2. So 1, 3 is equal to -1, 2 plus vector w. So how do we figure out vector w? We need to subtract this from both sides of the equation. So 1, 3 minus -1, 2 equals w. And how do we subtract vectors again? So x component minus x component, y component minus y component. What's 1 minus -1? 2, and 3 minus 2 is 1. Okay, so we can write u as the projection of u onto v. So this plus this. And the projection is -1, 2. And w is 2, 1. Okay, this is your answer.